right, now we're looking at the 7.4. We're studying surface area of some different shapes. So let's do a quick reminder on what perimeter is and compare that to the new surface area that we're going to be doing. So recall that perimeter is the measure of the total distance around the outside of a two-dimensional figure. So picture that you have a rectangle and you're adding up the width plus the length plus the width plus the length. You're adding that up, the distance around. In order for us to find that, we just find the length of each side and then add them all together. Well, surface area has some similarities. We're going to find the measure of the area of the outside surfaces instead of the distance around, the measure of the area of a three-dimensional figure. And then once we find the area of each face, we just add them all together. So here, find the length of each side, add them all together. Here, find the area of each face and add them all together. So we get this surface area formula for any solid, where we could be doing the surface area equal to the area of the base or bases, plus the total area of the lateral faces. And what does lateral faces means? It just means the sides. So we've got the base area plus the lateral area. And so surface area is equal to BA plus LA. That's our abbreviated formula. There it is. Surface area formula for any solid. So what do these stand for? We've got the BA being the area of two bases. P is the perimeter of one base. And H is the height of the prism. This is going to be your formula for the surface area of a right prism. All right. Why is the way you find base area different for different kinds of right prisms? It's because right prisms, I'm going to go reduce this again, hang on. Right prisms have different polygons for base. So this base area depends on the shape of the base. So that's why you're going to have different base area for different kinds of prisms. Which part of the right prism formula is for the prism's lateral area? And so of that formula up top, it's the pH. It's the perimeter of the base times the height of that prism. Why can't you use a quick formula for this? Because the lateral faces are not congruent. For the oblique when it's slanted, so you can't use a quick formula for the oblique. How do you find the surface area of an oblique prism then if we can't use the shortcut for it? How do we find it? You need to find the area of each base and each face, because they're all irregular sizes, and then sum them all up. Okay, so when it's oblique, when it's not a right prism, when it's oblique, you can't use the shortcut formula. You have to do all the different faces and bases and add them up. So in this next one, we do have a right prism though. So we're going to use this formula right up here, BA plus PH. And so they gave us the formula BA plus PH, and identify the shape. We see that it is a right prism. They are specifically a right triangle. and that's from the picture on the page before. So we know that the area of that base is 1/2 base times height. And if you look back at the picture, the base is 3 and the height is 4. So half of 12 is 6 units. That is my base area. But that's the base area of one base. So we need to multiply that by 2 to get 12 units as our full base area. And then this is going to go plug in to the base area formula in just a second. Now we go get the perimeter. Perimeter is adding up all those sides of that little base triangle. So 7 plus 5 is 12. My little perimeter is 12. And then the perimeter times the height of 20, that gives me 240 units. This is our lateral area. So this number here is going to come plug in for the lateral area. So here we go plugging in the numbers we just got above. It's 12 for the base area from right here, and it's 240 for the lateral area. 240 plus 12 is my answer of 252 units squared. Why is it units squared? Because surface area is a type of area. So we are going to square all these units as well for our answers. Okay, that's doing a right prism. We're now going to go through this for a couple of other shapes. Let's go for a regular pyramid. Here's the formula for a regular pyramid. So BA stands for the area of one base. P stands for the perimeter of one base. And S is the slant height. That's something different here. Picture this little pyramid we're about to see. Why is the way you find the base area different for different kinds of regular pyramids? That's because it depends on the shape of the base as well. If the base is a triangle, it would be a different formula. If the base is a rectangle, it would be a different formula. Which part of the regular pyramid formula is for the pyramid's lateral area? And you'll notice that there's a 1/2 of the perimeter times the slant height. That's the part that is the pyramid's lateral area. Why can't you use a quick formula for this? Because the lateral faces, if it's oblique, the lateral faces are not congruent. How do you find the surface area of an oblique then? When it's irregular in different sizes, you're going to have to get the area of the base, or bases, area of the base, sorry, it's a pyramid, so there's just one base, plus the area of all lateral faces, which could be different, and add them all up. All right, so let's go practice doing the pyramid one using that little formula. Here is the formula. We're going to go plug into it. We're going to notice that the shape of this base happens to be a square. Again, we're talking about this picture up here. So if we notice the base area is 12 by 12, can't we say that this is also 12 back here and this is 12? It's a square. So 12 by 12 means all those bottom pieces are 12. So the side times the side length would be 12 squared, or 144 units. That's the area of the base. And then the perimeter of the base is 12 plus 12 plus 12 plus 12, or half of 48. So we get 24. So take that perimeter times the slant height, and take half of it, that's 240 square units. So now that we've got our base area, and now that we've got our lateral area, we can add those together. 24 plus 240 gives us 240 Oh, sorry guys. Did you notice what I did? This guy appears 144 from right here. And then we get our 384 square units. All good? All right. On to our third of our fourth shape. This guy is surface area for a right cylinder. And here's this formula. So now we're back to like the circles chapter last chapter, where we're going to start seeing things about a radius, etc. So radius is going to be right here, and height is our h. Which part of the formula for the area of the cylinder's two bases? And that's the 2 pi r squared. So that's because there are two circles times the area of pi r squared. So we get two circles times pi r squared, 2 pi r squared. Which part of the formula is for the area of the cylinder's lateral face? So we take the perimeter times the height, so it's 2 pi rh. That's the part of the formula for the lateral face. How do you know the cylinder is a right cylinder? If the two bases are aligned, meaning one is right on top of the other. They're exactly over each other. Why can't you use a quick formula for this? When it's oblique, the lateral face shape is irregular. So you can't use this little formula. So let's go do a right cylinder using the formula. And they gave us a little formula right here, 2 pi r squared plus 2 pi rh. So you'll notice that the radius in the picture right here was given as 9. So 9 times 9, or 9 squared, is 81 pi. And we know that that's the area of the base. There's a top and a bottom, so 2 times that 81 pi is 162 pi units. That's our base area. We're going to take this base area, plug it in down here in just a second. Next, we go get the perimeter, 2 pi r, or 18 pi, and we take that 18 pi times 23, and that gives us our lateral area of 414 pi units. And we're going to take that and go plug it in down here into the lateral area. And then we can add and get our final answer. So 162 pi units plus 414 pi units gives us a total of, you got it, 576 pi units. And this one's for the cylinder. Last but not least, we're going to right cone. Here's the formula for right cone. Which part of the formula is for the area of the cone's base? And we know that the area of a circle is pi r squared. Which part of the formula is for the cone's lateral face? It's this pi times radius times the slant height, this back part right here. How do you know the cone is a right cone? When the vertex is centered above the base, right when it's in the middle. And then why can't we use a quick formula for oblique when it's not a right cone? Because the shape is irregular. Okay, here's our picture. We've got a radius of 9 again. We've got a height of 12. We've got a slant height of 15. Let's go plug into our different parts and see what we get. So 9 squared again is 81 pi. And here we've got pi times 9 is just 9 pi. And then we go plug this in, 9 times 15, that's going to give us 135 pi units. That's our lateral area. And then we got our area of 81 for the base area for right here. Let's go plug in. 81 plus 135, I think that gives us 216 pi units squared. And that's our last one of the study guide. Let's go do the checkup before we do the quiz.